Welcome to the project demonstration of get zone free control scheme for HVS buck boost converter. So in this, the main application of this project is, as we know that when we are switching between the buck and boost converter, so then the microcontroller will switch between the two modes, so buck and boost. Then there will be time gap between these two modes. So then the microcontroller will delay the output to switch between the buck and boost. So the delay was happened because of the only one circuit. So previously, as we know, that buck boost converter consists of two MOSFETs and two inductors, one capacitor, one diode. And in this one, to eliminate the dead zone, nothing but when we are switching for example, consider we are under the boost mode. So then the voltage is around 12.5 or 14. Then we are switching into the buck mode. Then there will be time gap to discharge that. So that will be eliminated in this model. So for that we are using two different sections. One is the buck, another is the boost mode. So when we are switching in the buck mode, these two MOSFETs are switching to step down the voltage, buck nothing but to reduce the output voltage with respect of input voltage. So then when we switching into the boost mode again, so that will be identified our microcontroller whenever the voltage is increases above 12.5 13 volts, then we need to go with the buck mode, and when it is below 10 volts and above 8 volts, then it will switching into the boost mode. So then these two MOSFETs will work in the buck mode and these two MOSFETs will work for the boost mode. So this is the main block diagram, proposed block diagram of our project. So there we can see the two MOSFETs. So then when we go with the buck mode 1, so the VG1 and VG1S, so these two MOSFETs will work, and in the boost mode these two MOSFETs will work. So then these two will be continuously on state only. So coming to the buck mode 1, so when we are decreasing the on time for these two MOSFETs, then there is a less charging time for the capacitor as well as the inductor. So then we'll get the less voltage. At that time, these two MOSFETs will continuously on only. And when we go into the boost mode, these two continuously on. And then we are going to provide the maximum on time for these two MOSFETs, so that we'll get the maximum charging time for the capacitor and inductor. So there we'll get the highest current, highest voltage with sufficient power for the load. So here the thing is like we are going to charge a battery from the transformer that we need to provide the 230 volts AC inputs. So this transformer will step down the 230 volts AC to 12 volts AC, and that is the input to this regulated power supply board. On this we have the two stages. One is a rectifier, so 4 diodes, IN4007 diodes will act as a bridge rectifier. After that we will get pulsating DC. So this is the smoothing capacitor. To remove the pulses we will get the pure DC voltage. And after that there is a LED indication along with two diodes, IN4007 same. So these two diodes purpose is whenever the battery become the high potential, and then these two diodes will stop the current flow from the battery to the charging circuits in order to protect the transformer as well as the charging circuits. So because the diodes are connected in forward from the transformer to the battery, in reverse from the battery to the transformer. So after that the controller keep on monitoring the input voltage with reference with this potentiometer. So we are going to change the battery voltage here. So manually we are going to change that. In generally, when the battery is fully charged, continuously we will get around 12.5 to 13.5 volts. So in order to change that, we are using a potentiometer which will act as a variable resistor to change the voltage from 0 to maximum of V in, that is a battery voltage. So when we set that, so as we know that for buck operation and boost operation there is certain limit for the voltage. So whenever it is above 12.5 it will go with the buck operation to get the near to 12.5, and when it is above 8 volts then only we can boost up that to 12.5 volts. And this is the voltage sensor. We are going to measure the output voltage of this boost converter. So let us see demonstration. So before switching on the kit, keep the battery in fully charged, then on. So here we are using the LCD display to measure the voltage and welcome message. Right. So we set the voltage for the 2.5. So we are increasing that. When the controller get the sufficient voltage, so then without any delay, maximum 1 second of delay was happened. So now it is in boost mode. That will be displayed on the LCD screen. So when it is about 12.5, then it will go to the buck mode again. So the maximum voltage from our battery we are getting that, and the output as we are doing the buck operation 13.0 volts. So these pin connections for the reference voltage at A0 as a battery voltage, and the output of this buck boost converter, the dead zone free buck boost converter at A1 pin, and the MOSFETs we have interface at C0, C1, C2, C3, and LCD at pin number B2 to B7 on this motherboard. So there we are going to provide the input of 12 volts directly from the boost converter to the motherboard. So but we need to provide the 5 volts power supply, as controller working voltage is 5 volts only. For that purpose we are using 7805 regulator. So we will get 5 volts DC power supply. And next, this is the reset switch to restart the microcontroller. And this steel plate one is a crystal oscillator which will provide the 20 megahertz clock frequency to the microcontroller. So the main purpose of the crystal oscillator is, so based on the clock pulse, controller will execute instructions, 1 clock pulse per instruction, so that we are providing 20 mega clock pulses per second, so that controller can execute 20 mega instructions per second. So coming to the MOSFET ratings on our buck boost circuit board, so we are using IRF 540 MOSFETs, and the capacitor ratings are 1000 microfarad up to 25 volts maximum, and inductor is 100 microhenry. So that voltage can be the main purpose of the inductor in any buck boost converter is to maintain the current. As you know that current stability purpose we are using inductors, voltage stability purpose we are using capacitors in electrical circuits.